Hello everyone, welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. आज हम लोग जो डिस्कस करने वाले हैं वो ऑपरेटिंग सिस्टम की क्लास करने वाले हैं जो कि आपकी क्लास 19 है। ऑलरेडी हमने 18th क्लासेस कर लिया है। फर्स्ट ऑफ ऑल, अगर आप हमारे चैनल फर्स्ट टाइम देख रहे हो या अभी तक आपने हमारे चैनल को सब्सक्राइब नहीं किया है, इट्स अ ह्यूज रिक्वेस्ट कि आप हमारे चैनल को सब्सक्राइब करो सो दैट हम जो भी वीडियोस डालें वो आपके पास सबसे पहले पहुंचे। एंड सेकेंडली, अगर आपको हमारा वीडियो अच्छा लगे तो प्लीज़ हमारे वीडियो को लाइक, शेयर और सब्सक्राइब करो सो दैट ज़्यादा से ज़्यादा लोग के पास वीडियो पहुंचे और ज़्यादा से ज़्यादा लोग इसका यूटिलाइजेशन भी कर सके। In respect to that, we are now we are discussing unit 4 here. Unit third, unit second, unit 1 हम already discuss कर चुके हैं. unit 4 हम discuss कर रहे हैं. Hopefully इस क्लास में अगर ये ज़्यादा exceed नहीं हुआ तो hopefully इस क्लास में हम unit 4 को complete करके unit 5 within next class we'll start with it. So for the first question for the session, that what we have to discuss here, the question we have is: consider a demand page system. Page tables are stored in the main memory, which has an access time of 100 nanoseconds, and the TLB can hold a page table entries and has an access time of 10 nanoseconds. During the execution of the process, it is found that 80% of the time a required page table entry exists in the TLB, and only 2% of the references cause page faults here. The average time of the services page fault is 2 milliseconds, so we have to compute the effective memory access time, that what we have to find it out. सो जैसा कि लास्ट क्लास में भी मैंने आपको लास्ट क्वेश्चन कराया था, वो आपको इसी बेसिस पे कराया था कि हाउ टू फाइंड इट आउट, वहाँ पे हम लोग ने फाइंड किया था रेट ऑफ एन इफेक्टिव एक्सेस टाइम विद दैट इज नो मोर देन द 200 नैनो सेकेंड्स. तो ऑलरेडी मैक्सिमम एक्सेप्टेबल पेज फॉल्ट्स हमने उसमें डिस्कस किया था, पेज रेट. अभी हम जो डिस्कस करेंगे दैट व्हाट वी विल फाइंड इट आउट इज द एवरेज टाइम ऑफ द सर्विसेज पेज फॉल्ट, दैट इन 2 milliseconds. And of course we will have to find out the effective memory access time. So we'll go ahead. Effective access time जो हमारा होगा that is 0.8, and 0.8 multiply by 1 seconds, and 0.1 that is 2 seconds here. 0.1 and then we have 5002 seconds here. तो जब हम इसको टोटली मल्टीप्लाई करेंगे उसके बाद इसको भी मल्टीप्लाई करेंगे, then we add in all three, we'll get 501.2 millisecond, that is 0.5 millisecond here. This will be the right answer in the millisecond if I'm talking about what they had told you in the form of the pitch fault. They had given you 2 milliseconds here. Now with regard of that, after this completing this, we'll start with the demand paging. Demand paging क्या होता है, that what we have to discuss, because that is an important point, even though that is an important topic, that what we have to discuss here. In respect to the demand paging की अगर हम बात करते हैं, in a demand paging, a page is loaded into the primary memory only when the process references it. तो बेसिकली डिमांड पेजिंग की अगर हम बात करते हैं तो डिमांड पेजिंग में क्या होता है, पेज जो है वो लोड होता है प्राइमरी मेमोरी में, और तभी होता है when the process references it, जब उसको वो प्रोसेस रेफरेंस करता है. उसके साथ साथ ये एक सिंपली फेच पॉलिसी होती है जो हम वर्चुअल मेमोरी में इम्प्लीमेंट करते हैं for the demand paging here. Demand paging is that guarantees that the system brings into the primary memory only those pages that process actually need. It involves interaction between the hardware and the software component of the virtual memory. तो जो virtual memory होती है उस पे हार्डवेयर और आपका सॉफ्टवेयर का जो इंटरेक्शन होता है वो आपका डिमांड पेजिंग करवाता है. पेजिंग विल स्वैपिंग मेथड विल बिकम एज डिमांड पेजिंग. जब हम जब पेजिंग को हम स्वैप करते हैं, स्वैपिंग मेथड उसमें यूज करते हैं, तो हमारा डिमांड पेजिंग कॉन्सेप्ट यूज होता है. और प्रोसेस ऑफ लॉजिकल एड्रेसेस पेज इज स्टोर्ड इन द सेकेंडरी स्टोरेज डिवाइसेस, एज यू ऑल्सो नो. विद रिगार्ड ऑफ दिस हियर, in regard of the demand paging requires that the page map table, demand paging जो होता है वो आपका page map table required करता है for each process that keep the track of each page as it is loaded or removed from the primary memory. Okay, चाहे वो load किया जा रहा हो चाहे remove किया जा रहा हो primary memory में. When user want to execute a process, जब कोई user जो है वो आपका execute करना चाह रहा है process को, तो users swap a process into a memory. Lazy swapper is used for swapping the process into the memory, and the lazy swapper swaps the pages whenever needed. तो बेसिकली अगर हम बात करते हैं यूजर्स के कंसेप्ट में, यूजर जब अगर वो प्रोसेस को एग्जीक्यूट करना चाहता है तो वो उसको यूज करता है. उसके साथ साथ जो यूजर है वो स्वैप भी करता है प्रोसेस को मेमोरी में. और जो लेजी स्वैपर्स होते हैं वो आपका स्वैपिंग प्रोसेस को यूज करते हैं मेमोरी में, एज वेल एज जो लेजी स्वैपर्स होते हैं वो पेजेस को भी स्वैप करते हैं जब भी उनको रिक्वायरमेंट होती है. विद रिगार्ड ऑफ दैट वी हैव another here, that is a working of demand paging. अभी demand paging क्या होता है, that what we had discussed here. पर किस तरह से demand paging work करता है, that what we have to discuss here. The working of demand paging, पहला है प्रोग्राम अटेम्प्ट्स टू फाइंड अ पेज. पहली बात तो वो प्रोग्राम जो है वो फाइंड करता है उस पेज को कि वो है का. इफ द पेज इज लोकेटेड इन द प्राइमरी मेमोरी देन द प्रोग्राम एग्जीक्यूट. जब वो अगर वो पेज जो है वो आपका प्राइमरी मेमोरी में है तब वो आपका एग्जीक्यूट करता है उस प्रोग्राम को. If the page cannot be found in the primary memory, then the page fault occurs. और अगर वो आपका प्राइमरी मेमोरी में पेज नहीं फाइंड आउट होता है तो फिर आपका पेज फॉल्ट जो है वो आपका अकर हो जाता है. Memory references is checked for the required page to determine it is a valid reference for the location on the secondary storage, where if it isn't, then page will be required page, and if the process is terminated. अगर वो आपका रिक्वायर्ड सेकेंडरी मेमोरी स्टोरेज में होता है, लोकेशन पे वैलिड रेफरेंस के साथ होता है आपका, तब तो वो आपका ऑब्वियस सी बात है वैलिड पेज होता है और फिर वो आगे आपका रिक्वायर्ड पेज बताता है. अदरवाइज अगर वो नहीं होता तो फिर वहीं पे ही आपका जो प्रोसेस है वो टर्मिनेट कर दिया जाता है. शेड्यूल्ड डिस्क ऑपरेशन टू रीड द रिक्वायर्ड पेज इनटू द मेमोरी. शेड्यूल्ड डिस्क ऑपरेशन जो होता है वो आपका रीड करने के लिए यूज होता है कि वो आपका जो रिक्वायर्ड पेज है उसको प्राइमरी मेमोरी में रीड कर सके. With regard of the sixth point of the working as demand, working of demand paging, that is restart the instruction that was interrupted by the OS operating system trap. तो फिर से इंस्ट्रक्शन को से रिस्टार्ट करते हैं कि वो इंटरप्ट जो आया ऑपरेटिंग सिस्टम में ट्रैप पे वो हम उसको सही कर सकें. Now this is the working of demand paging. You can just go through with and you can just write it down so that you can easily go through with and you can write it down, and as well as you can write it down in the examination paper as well. With regard of this, we'll go ahead and discuss about the demand paging via a diagram where primary memory as well as the secondary storage devices performs, and that from the primary memory, that from the OS that it goes, the process removed from the memory to the secondary storage devices, and the secondary storage devices say that is loaded into the memory here. So what we'll discuss here in respect to the demand paging, and as well as with regard of that also we'll discuss the page table entries with that valid or invalid, and we will discuss कि वो valid और invalid किस तरह से represent करते हैं that also. So moving ahead with regard of the demand paging here. So this is a primary memory. In this is a operating system. ये आपका सेकेंडरी स्टोरेज डिवाइस है. जब प्राइमरी मेमोरी से स्टोरेज सेकेंडरी स्टोरेज डिवाइस में जा रहा है दैट प्रोसेस रिमूव फ्रॉम द मेमोरी. प्रोसेस रिमूव्ड हो रहा है, सेकेंडरी स्टोरेज डिवाइस में जा रहा है. पर जब सेकेंडरी स्टोरेज डिवाइसेस से प्राइमरी मेमोरी में जा रहा है दैट प्रोसेस लोडेड इनटू द मेमोरी. दिस इज व्हाट वी कैन नोन एज demand paging here. With regard of the demand paging, we'll discuss some of the points related to that, and with reference to that we'll discuss some more points regarding this. डिमांड पेजिंग टेक सपोर्ट फ्रॉम द हार्डवेयर टू डिस्टिंग्विशेस द पेजेस. डिमांड पेजिंग जो है वो आपका सपोर्ट लेता है हार्डवेयर का कि वो पेजेस को डिस्टिंग्विश कर सके. इस वजह से वैलिड और इनवैलिड बिट मेथड जो होते हैं वो इसके लिए यूज होते हैं फॉर द डिस्टिंग्विशिंग द पेजेस. As well as this method gives the idea about the page location as well as page may be the primary memory or in the secondary storage here. So if the valid bit is set, then the required page is stored in the primary memory. When an invalid bit is set, and the page is on the secondary storage disk here. तो अगर वैलिड आपका बिट है तो अब सेट हुआ है तो ऑब्वियस सी बात है जो रिक्वायर्ड पेज होगा वो आपका प्राइमरी मेमोरी में स्टोर होगा. बट अगर इनवैलिड बिट सेट हो गया है तो पेज जो आपका होगा वो सेकेंडरी स्टोरेज डिस्क में आपका सेट होगा. वैलिड इनवैलिड बिट फील्ड इज अटैच विद अ पेज टेबल. और चाहे वो वैलिड हो बिट हो चाहे आपका इनवैलिड बिट हो, दोनों ही आपका वैलिड एंड इनवैलिड फील्ड जो बिट होते हैं वो आपके पेज टेबल में ही अटैच्ड होते हैं. Now with regard of that we'll move ahead here with reference to that कि valid bit कैसे हम बताएंगे और invalid bit कैसे बताएंगे with in the terms of the 0 and 1, and then we'll discuss the figure as well. So go ahead here. So here the valid invalid bit field contain a boolean value. Boolean value contain करता है valid और invalid bit to indicate whether the page exists in the memory or not. अगर वो 0 डिनोट करता है that means not in the memory. 0 का मतलब है वो मेमोरी में नहीं है, और 1 अगर वो डिनोट कर रहा है इसका मतलब है कि वो मेमोरी में है, एग्जिस्ट कर रहा है. Initially all the valid and invalid entries are set to 0. सब स्टार्टिंग में तो सारी जो चाहे वो आपकी वैलिड हो चाहे इनवैलिड हो दोनों ही वैल्यूज जो होती हैं वो आपकी पहले 0 ही होती है. The information is used for the page replacement algorithm. Page fault leads to the page replacement operation to load the required page in the primary memory, where a failure to find a page in the memory is called a page fault. जितने पेज आपके फेलर होते हैं that what you are finding out and that what in the memory, and that is known as page fault here. With regard of that we'll discuss here with the process that page table entries in the in a valid or invalid way. So this is a frame here. Okay, ये frame है, यहाँ पे ये 0 है let that be 0 here, then it is 1, फिर ये 2 है, and then ये 3 है, and then ये 4 है, and then so on, ये 5 है. ठीक है. उसके बाद यहाँ पे क्या होता है, ये वैलिड और वैलिड इनवैलिड में यहाँ पे जस्ट लाइक ये वैलिड और इनवैलिड लिस्ट है, वैलिड एंड इनवैलिड लिस्ट. ठीक. सॉरी, वैलिड एंड इनवैलिड बिट. तो उसमें क्या होता है, यहाँ पे ये 1 है, ये 0 है, फिर ये 1 है, फिर ये 0, फिर 1 है, and then of course we have a 0 and then we 1. तो ये जो आपका है वो आपका बाई डायरेक्शनल होता है. दिस इज अ बाई डायरेक्शनल हियर. So this goes with the table that what I had discussed about the primary memory. तो ये primary memory में जाता है. I will write it down. प्राइमरी मेमोरी. तो ये पूरा प्रोसेस होता है. दिस इज ये आपकी ये जो टेबल है, दिस इज नोन एज पेज टेबल. तो ये जो आपका प्रोसेस है, दिस इज द पेज टेबल एंट्रीज विद वैलिड एंड इनवैलिड बिट हियर. ओके. सो विद रिगार्ड ऑफ दिस, द डिमांड पेजिंग इज द मोस्ट एफिशिएंट व्हेन यूजर्स आर अवेयर ऑफ द पेज साइज यूज्ड बाय द ऑपरेटिंग सिस्टम. तो डिमांड पेजिंग जो है वो बहुत ही एफिशिएंट होता है, और तभी ये एफिशिएंट होता है जब यूजर्स जो है वो उसके पेज साइज के बारे में अवेयर हो ऑपरेटिंग सिस्टम के. Now moving ahead with the page replacement algorithm. Page replacement algorithm क्या कहती है? Page replacement algorithm में Bilardi's algorithm जो है वो बहुत ही important है. Bilardi's anomaly जो है, that is page fault rate में increase as number of allocated frame is increases. तो page fault जो है वो आपका उसका rate तब increase करता जाएगा जब आपके number of allocated frames भी अगर increase करते जा रहे हैं. For some pages replacement algorithm, the page fault rate may increase or the number of allocated frame may increase. With respect to that, FIFO replacement algorithm suffer from Bilardi's anomalies. तो FIFO first in first out जो replacement algorithm है आपकी page replacement algorithm के terms में, वो आपका जो है वो Bilardi's anomalies को face करती है. अब इसी के रिगार्डिंग हम एक स्ट्रिंग लेंगे. स्ट्रिंग के लेके उसको हम फिर पेज फॉल्ट साइज के अकॉर्डिंगली हम उसको सॉल्व करेंगे. देन विल गेट टू नो कि कैसे हम Bilardi's anomalies को सॉल्व करते हैं विद रेफरेंस टू द पेज रिप्लेसमेंट एल्गोरिथम हियर. सो विल गो अहेड हियर. This is consider the reference string 1 2 3 4 1 2 5 1 2 3 4 5. So this is the string here, reference string. So we'll discuss page frame जब size आपका 3 था. Here reference string दिया है इस टाइम में जो कि आपको ऑलरेडी गिवन है 1 2 3 4 1 2 5 1 2 3 4 5. ओके. पेज फ्रेम 1 है, पेज फ्रेम 2 है, पेज फ्रेम 3 तक बोला है, तो पेज फ्रेम 3 तक ही हम एक्सटेंड करेंगे. एंड देन पेज फॉल्ट्स कितने हैं दैट विल डू देयर. सो टोटल 1 स्ट्रिंग के बाद पेज फ्रेम 1 में यहाँ पे 1 है. सेम फॉर द 1 1 4 4 4 5 5 5 5 5 एंड 5. फॉर पेज फ्रेम 2 दिस इज नॉट एग्जिस्टिंग. 2 2 2 1 1 1 1 1 3 3 3. पेज फ्रेम 3 के लिए ये दोनों में नहीं है, 1 2 के केस में. रेफरेंस स्ट्रिंग 1 2 में नहीं है. देन व्हाट वी हैव इज we have here is 3 3 3 3 2 2 2 2 2 4 4. Now the number of the page faults, page fault page fault page fault page fault फिर page fault फिर page fault फिर page fault, and then यहाँ पे नहीं है page fault, यहाँ पे page faults है, यहाँ पे नहीं है. तो total number of page faults कितने हुए 1 2 3 4 5 6 7 8 and 9. तो total number of जो आपके page faults हैं वो 9 है. Okay, with reference to the page frame size 3 here. Now moving ahead with this, now अब हम उसके बाद पेज फ्रेम साइज 4 बढ़ा दिया, एक पेज फ्रेम बढ़ा दिया आपका, पहले 3 था अब ये 4 हो गया. रेफरेंस स्ट्रिंग सेम रहेगी 1 2 3 4 5 4 1 2 5 1 2 3 4 5. पेज फ्रेम 1 पेज फ्रेम 2 पेज फ्रेम 3 पेज फ्रेम 4 एंड देन पेज फॉल्ट. इसके रेफरेंस में 1 1 1 1 1 5 5 5 5 4 4. Then for the page frame 2 dash, that is not existing here, 2 2 2 2 2 2 and 1 1 1 1 and then 5. पेज फ्रेम 3 के लिए यहाँ पे दोनों में नहीं है, फिर 3 3 3 3 3 3 3 2 2 2 and then 2. पेज फ्रेम 4 के लिए this is 4 is not existing, 4 4 4 4 4 and then 3 3 3 here. पेज फॉल्ट एग्जिस्टिंग में यहाँ पे बात करते हैं अगर पेज फॉल्ट एग्जिस्टेंस के लिए, तो यहाँ पे पेज फॉल्ट है, यहाँ पे भी पेज फॉल्ट अकरेंस होगा, यहाँ पे पेज फॉल्ट, यहाँ पे भी पेज फॉल्ट, इन दोनों में नहीं है, फिर बाकी में सब में पेज फॉल्ट है. टोटल नंबर ऑफ पेज फॉल्ट्स कितने हैं 1 2 3 4 and then 5 6 7 8 9 and 10. Total number of page faults कितने हुए 10 हुए. This is for this. Now moving ahead with another here and that we have to discuss here. So this is the question, that is, consider the following page reference string, that is 1 2 3 4 2 1 5 6 2 1 2 1 and 5 6. How many page faults would occur for the following replacement algorithm, assuming the three frames here, जिसमें से पहला है LRU पेज रिप्लेसमेंट एंड FIFO पेज रिप्लेसमेंट एंड ऑप्टिमल पेज रिप्लेसमेंट. हम इनके रिप्लेसमेंट पेज रिप्लेसमेंट के अकॉर्डिंग, इन पेज रिप्लेसमेंट एल्गोरिथम के अकॉर्डिंग हम उसको बनाएंगे. अकॉर्डिंग टू दैट द रेफरेंस स्ट्रिंग व्हाट दे हैड गिवन यू इज 1 2 3 4 2 1 5 6 2 1 2 1 5 6 here. For the first one we will find it out. LRU page replacement के लिए हम बनाएंगे and we'll go ahead here with forming a table here, and we can just go ahead by doing like we are making a table here. तो पहले तो हम string reference string बनाएंगे जिसमें हमें जो already strings दी हुई है तो वो तो string के लिए हो जाएगा. फिर second आपका जो row बनेगा that is your page frame. पेज फ्रेम जो आपका बनेगा दैट इज़ फॉर 0 एंड दैट इज़ पेज फ्रेम आपका 1 के लिए, फिर पेज फ्रेम आपका 2 के लिए, एंड देन वी विल बी काउंटिंग आउट योर पेज फॉल्ट हियर. ओके, सो उसके बाद यहाँ पे रेफरेंस स्ट्रिंग बनेगी. सो विल गो अहेड लेट सी की वो कितने हैं. सो देन अकॉर्डिंग टू दैट विल पार्ट 1 2 3 4 5 6 and then 7 8 9 10 11 12 13 14. So we will be having a 14 column here. This is 1 2 3 4 5 6 7 8. So here we have a replacement algorithm that will do for well, first we'll write it down the string what they had given you 1 2 3 4, and then we have a 2 1 and then 5 6, and then we have 2 1 2 1, and that what we'll write here, and after that we have a 5, and then again we have a 6 here. तो ये हमारे पास जो स्ट्रिंग है पेज फ्रेम 0 के लिए क्या होगा, जब हमारा रेफरेंस स्ट्रिंग 1 है that will be the 1, and for the 2 1 is it, that is also the same, and the 1, and that is also the 1 here. With respect to the fourth string we have a 4 for the page frame 0, and then for 2 also we have 4 here, and then also we have 4 here, and then for the 5 we have a 5 for the page frame 0. 6 के लिए भी 5 ही रहेगा, 2 के लिए भी 5 रहेगा, फिर अगेन 1 आ गया तो 1 रहेगा, then we have फिर again 1, and then again 1 1 and 1. This is for the page frame 0 here. 1 1 1 4 4 4 5 5 5 1 1 1 1 1. For the page frame 1 here, this is not existing. Then for the page frame 2, that it starts with 2 here, and then also 2, then again we have a 2 here, and then again we have 2 2, and then we have again 2 here. With respect to this fifth one, when we have a reference string C, a 6 here, so that will be the 6, and then will it goes till 1, that is 6 6, and then 6, and then after that we have 5 and then 5. Now for the page frame 2 here, we will start with this, and here we don't exist with these two strings here, with the reference string 1 and reference string 2 here. Then we have again starting with the reference string 3, then it will be the 3 here. So here we have a 1, and then again we have 1, and then we have again 1. Then we have start with reference string जब हमारे पास 2 आएगा, then for the page frame 2 we have a 2 here, and then again we have 2 2 and then 2 and then 2, and the last जब हमारा reference string 6 है, then it will end at 6 here with the page frame 2. Now moving ahead with the page faults. तो page faults यहाँ पे होगा, यहाँ पे भी है, then we have here also पेज फॉल्ट, एंड देन पेज फॉल्ट है ऑल्सो सेम फॉर दिस, एंड यहाँ नहीं है, फिर यहाँ पे भी पेज फॉल्ट है, यहाँ पे भी पेज फॉल्ट है, यहाँ पे भी पेज फॉल्ट है, एंड देन ऑफ कोर्स पेज फॉल्ट है, एंड देन पेज फॉल्ट है ऑल्सो, एंड यहाँ पे ये दोनों में पेज फॉल्ट ना होके फिर यहाँ पे पेज फॉल्ट है, एंड यहाँ पे पेज फॉल्ट है. सो बेसिकली अगर मैं बात करती हूँ नंबर ऑफ पेज फॉल्ट की, व्हीकल जस्ट काउंट इट डाउन 1 2 3 4 5 6 7 8 9 10 11. So total we have 11 page fault. We can say that total number of page faults for the LRU page replacement we have here 11. FIFO पेज रिप्लेसमेंट की अगर हम बात करते हैं तो FIFO पेज रिप्लेसमेंट के लिए फिर से हम अगेन टेबल बनाएंगे. विल जस्ट कंडक्टिंग अ टेबल हियर एंड दैट इज FIFO पेज रिप्लेसमेंट के लिए पहले तो यहाँ पे स्ट्रिंग्स रहेंगी, फिर ये हमारा आएगा पेज फ्रेम 0 के लिए, फिर पेज फ्रेम 1 के लिए, पेज फ्रेम 2 के लिए, and then we have page frame of 2, and then we have here that is your page faults. Okay, so we'll count number of page faults. So we'll write it down. First we'll write it down the string here, as well as you know very well. So that will be the string is 1 2 3, and then we have 4, then we have 2, then we have 1 here, and then 5 6 2 1, 5 6 2 1, and then we have 2 1 5 6, so 2 1 5 and then 6. So this is the this is the reference string that has been given in the question. So for the page frame 1, when we have a reference string 1, then we have starting from 1 1 and then 1 for reference to the FIFO page replacement. Then we start with then a 4 पे हमारा 4 start होगा, and that end at 5 here, and then after that it will start from the 6 page frame 0 के लिए, तो 6 से start होगा, and that will be 6 similar for this also and for this also, and then after that 5 पे फिर से 5 string start होगा. ओके, नेक्स्ट फॉर द पेज फ्रेम 1 के लिए बात करते हैं, तो यहाँ पे FIFO के लिए एग्जिस्टिंग नहीं है, देन इट इज विल बी द 2 हियर. Then again it will start with a 2, that it will be the 2 only. In the similarity, when there is a reference string 1, then it start with 1 here, and then we have 1 again for the reference string 6, and then after that we will have a 2 each while we have a string here and 6, then again it will be the 6 here. For the page frame 2 यहाँ पे नहीं exist कर रहा है, and for that page frame reference string 3 है, तो page frame 2 पे यहाँ पे 3 start होगा, 3, and then again it will be the 3 here, then 3 and then 3 for the 1, and then after that we'll have a reference string 5, तो वहाँ पे 5 start होगा, and then it will goes on, and after that जहाँ पे वो 1 आपका आएगा वैसे ही फिर से 1 start होगा, and then we have here 1 each here. Okay, this is for the page frame 2. Now we'll count it on number of page faults here. So first we'll find it out how many page fault are there. Page fault यहाँ पे भी होगा, page fault यहाँ पे भी होगा, page fault यहाँ पे भी होगा, फिर यहाँ नहीं है, and then यहाँ पे भी यहाँ पे होगा, यहाँ पे होगा, and then we have here also, and then we have यहाँ पे 1 है page, sorry, this is the one here na. So we'll count it down and accordingly here, and with respect to that particular question we'll just go ahead. We have a page faults here, page fault here also, and then we have page fault here also, and then we have your page fault again, we have page fault with reference to that page fault, and then we have page fault here, and then we have according to that we will have only यहाँ पे एक नहीं है, sorry यहाँ पे नहीं है, और ये होगा page fault, and then we have your page fault here also, यहाँ पे नहीं है, यहाँ पे नहीं है, then page fault and then page fault here. So total number of page faults हमारे पास है 1 2 3 4 5 6 7 8 9 10 11. So total numbers of page faults यहाँ पे भी जो है वो total number of page fault जो आपके हैं वो 11 है, and for the FIFO page replacement. Moving ahead with another pattern that what we have to discuss is optimal page replacement here, and that is, so optimal page replacement के लिए भी we have a string here first, and then we'll have your page frame 0, then page frame 1, page frame 2, and then we have a page faults here. Okay, so according to that we have a 14th a string, a reference string, so we'll just go ahead and with we'll write it down 14th column here. 1, this is 2, this is 3, this is 4, this is 5 6, then 7, and then we have 8 here, then 9, then we have 10, then we have 11, then we have 12, then we have 13, and then we have 14th. ओके, तो अब इसके लिए हम रेफरेंस स्ट्रिंग फाइंड आउट कर, पहले रेफरेंस स्ट्रिंग जो हमें गिवन है क्वेश्चन में हम वो लिखेंगे, एंड अकॉर्डिंग टू दैट विल परफॉर्म हाउ पेज फ्रेम 0, पेज फ्रेम 1, पेज फ्रेम 2, एंड एज वेल एज पेज फॉल्ट्स हियर. So we'll go ahead with the reference string that will be 1 2, and then we have 3, then we have 4 2, and then we have 1 5, 6, then 2, 1, 2, and then we have 1, 5, and then 6. For the page frame 0, we have for the reference string 1 here, and this is also 1, and this is also 1. This will be also 1, 1, 1, 1, 1, 1, 1, 1 here, and for the same 1 here. If 5 आएगा, then it will be the page frame 0 के लिए, it will be 5, and that is also the 5 here. Page frame 1 के लिए it not exist, and from this is 2 here. And with the whole page frame 1 के लिए अगर इस रेफरेंस की बात करते हैं ऑप्टिमल पेज रिप्लेसमेंट में, तो वो ऑप्टिमल पेज रिप्लेसमेंट में सारे ही जो आपके स्ट्रिंग हो, दैट विल बी द स्टार्टिंग फ्रॉम द 2 एंड दैट विल बी एंडिंग टिल द 2 हियर आल्सो. सो ये ऑल टोटल आपका 2 होगा. पेज फ्रेम 2 की बात करते हैं तो इट विल नॉट एग्जिस्ट एंड देन स्टार्ट विद 3 ईयर, देन 4 आया तो 4 रहेगा, एंड दैट विल बी 4 हियर, एंड जब तक 5 नहीं आता फिर 5 आएगा तो फिर वो 5 आएगा, फिर 6 आ गया क्योंकि वो ज़्यादा था तो 6 ही रहेगा, एंड दैट विल एंड अप विद द 6 ओनली. अब नंबर ऑफ पेज फॉल्ट्स काउंट करते हैं. सो हियर वी हैव अ पेज फॉल्ट, 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 एंड देन फिर ये दोनों में नहीं है, देन यहाँ पे भी हमारा पेज फॉल्ट होगा, यहाँ पे भी पेज फॉल्ट होगा, एंड देन फिर उसके बाद यहाँ पे पेज फॉल्ट होगा. तो टोटल नंबर ऑफ पेज फॉल्ट्स कहाँ पे, 1 2 3 4 एंड देन 5 6 एंड देन 7. तो टोटल नंबर आप बोल सकते हो, टोटल नंबर ऑफ पेज फॉल्ट्स we have here is equals to 7. Now move ahead with another question, and that is your question number, next question of the session here for the reference of the unit 4. Consider the following in reference string, that is 1 2 1 2 and then 3, and then we have 4 2 1 5 6 2 1 2 3 7 6 3 2 1 2 3 6. How many page faults will occur for first in first out, then LRU page replacement algorithm, and assuming these for the 4 frames initially empty in these each cases. हर एक केस में आपको हर जो रेफरेंस स्ट्रिंग है आपको ये दिख रहा है कि हर एक फ्रेम जो है वो इनिशियली एम्प्टी है, देन यू हैव टू फिल इट आउट. सो फर्स्ट विल फाइंड आउट इन द रिस्पेक्ट ऑफ द फर्स्ट इन फर्स्ट आउट where we have a page frame 3 here. With regard of that, we will just do ahead, and first we'll find it out the table, and then after that we will be go ahead here. तो सबसे पहले तो हमें यहाँ पे मिलेगा पेज फ्रेम, okay, and then we have here for the page frame 0, then it is 1, and this is 2, and then we have a page fault here, so we'll count that also. Okay, so अब हम इसको find out करेंगे. पहले number of strings देख लेते हैं, reference string कितनी है. So we'll just count it down, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. तो almost 20 है. So we'll just go ahead with this. 1 2, then we have 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19, and then we have a 20 here. Okay, so we'll go ahead and we'll just find it out. इसमें हम पेज फ्रेम पहले चेकआउट रेफरेंस स्ट्रिंग जो हम लिखेंगे, उसके बाद हम पेज फ्रेम 0 के लिए, फिर पेज फ्रेम 1 के लिए, एंड फिर पेज फ्रेम 2 के लिए, एंड देन वील फाइंड इट आउट अगेन फॉर द पेज फॉल्ट हियर. सो विल गो अहेड एंड फाइंड इट आउट. तो उसके लिए पहले हमारे पास पेज फ्रेम पहले रेफरेंस स्ट्रिंग लिखते हैं, दैट इज 1 2, then we have 3 4, then we have 2 1 5, and then we have 6 2 1 here, and then we have 2 again, and then we have 3 7 6 here, and then we have 3 2 1 here, and then we have 2 3 6 here. So with reference to that page frame 0 के लिए हम बात करते हैं. So we'll start with the string here 1 1 and then 1, then again for the reference string of 4, that is start with 4 here, and it will end in at the 5, and then we'll start with the 6 here, and that will end the 6 here till the 2 1 2 string. Then from the 3, it starts with 3 here, and that will end up also with a 3, and then we have with 2, then we have 2 here, and with a reference to that 2 is end up with a 3, and then we have your 6 here. तो ये फर्स्ट इन फर्स्ट आउट है जिसमें पेज फ्रेम आपका 3 है, ये पेज फ्रेम 0 के लिए है. पेज फ्रेम 1 के लिए एग्जिस्टेंस फर्स्ट वाला तो रेफरेंस स्ट्रिंग एग्जिस्ट नहीं करता, फिर 2 है, then it will end up with a reference string 2 here, and then after that start with 1, and then it will end up with here that will when we have a reference string 6 start with then यहाँ पे 2 start हो गया तो 2 है, फिर उसके बाद that will end up with that is end up with 3 here, and then after that we will have 7, and that is 7 will end up with 7 string reference string or with a which frame that will be the reference string 2. Then after that 1, and then the 1 will be carried out within the whole screen here. For the page field 2 we have here this is not existing here, then start with a 3, and that will be starting with a 3 and end up with 1 here. Then 11 के बाद यहाँ पे reference string 5 है, so it will start with 5, and that will end up with till when it will not come first, and then 1 फिर से आएगा, then it will be ending up with the reference string 7, and then we have a 6 here, so 6 we have then it will goes on and it will end up here, and then we'll have 3, and then we have 3 reference string with the page frame 2 here. अब पेज फॉल्ट्स की बात करते हैं तो पेज फॉल्ट हमारा पेज फॉल्ट यहाँ पे भी, यहाँ पे भी है, यहाँ पे भी है, यहाँ पे भी है, and then after that we don't have here, and then we have page frame here also, and इधर भी है, फिर then यहाँ पे भी है, and then यहाँ पे भी है, and after that यहाँ पे नहीं है, यहाँ पे फिर page frame है, then we have page frame here also, page frame here also, and with regard of this so here we have page fault, here we have page fault, here we have page fault, and here we have a page fault here. So we'll count down number of page fault here, that is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15 and 16. The total number of first in first out for this reference string for the page frame 3 we have a that is these number of page faults here. And now we'll discuss first in first out page frame 4. This is for first in first out page frame 3, and this is for the first in first out for the page frame 4 here, and that will discussed here with reference to the page frame 0 1 2 3, and then we have a page fault count. So here we will draw this for the page frame 4 here, and that is यहाँ पे हमारे page frames होंगे, and that is page frame आपका 0 होगा, 1 होगा, 2 होगा, and then we have a 3 here, and then we will count it on the page faults here as well. तो page faults हम यहाँ count करेंगे, and then we have to go through with the reference string also, that what they had given you. चलो मैं यहाँ पे लिख देती हूँ, that is 1, फिर 2 है, and that we so this is the reference string here, that is 1 2 3 4 2 1 5 6 2 1 2 3, and then we have 7 6 3 2 1 2 3 6 here. Reference to that page frame 0 के लिए we have a string from starting with 1 here, and that will be the 1 until the unless the reference string 1 will not occur. Then after that 5 we have 5 here, and that until and unless the reference string 3 will not occur, and after that with the 3 here, that is start with 3, and it will start with 3 here, and it will end up with until and unless then 3 से छोटा नहीं जब तक आता, and that will be the 2 here, and for that sake after that 1 will be start, and that is will be in the whole string here. For the page frame 1 we'll go ahead, and that will have here 2, and until and unless that it will not come 6, then it will be that 2 only, and then after that it will be the 6, and this is also carried out when jab 6 से ज़्यादा नहीं आता, and that is 7, so we'll start with 7 here, and that unless until and unless it will not come with a reference string 3, then we'll go ahead, and then after that 3 will be so on. For the page frame 2 here, and that will be here we have this 3 here continuously with reference string till the reference string 6 here, and then we move ahead and further, and then we will solve this, and that will be the 2. For the reference string, until and unless it will not come as in the form of reference string 6, then it will be coming as 6, then we'll be having a reference string, the page frame we have a 6 here. Then for the page frame 3, we have this 3 will be not existing, and then we start with the 4 string, and that until and unless that will be not coming a 1 in the reference string, so we'll go ahead with 4 here, and that will be when we are counting out, so we'll be having a 1 here, and then after that will be start with 1, and that will be going through until and unless that 1 se zyada nahi aata, that will be the 2 just behind that, and that is your that is 2, and that will be move on further. Now talking about the page fault, for this string we have a page fault here, page fault, page fault here also, page fault here also, and then we have यहाँ पे नहीं है, यहाँ पे भी नहीं होगा, and then we have page fault here also, here also, and this is also, and then after that page fault यहाँ पे भी है, and then फिर 1 छोड़ के फिर यहाँ पे भी page fault है, and then we have page fault here also, page fault here also, and then page fault here also. Then after that नहीं, यहाँ पे नहीं होगा page fault, फिर यहाँ पे है page fault, यहाँ पे भी page fault है, फिर यहाँ पे नहीं है, and then we have page fault here. So total number of page faults कितने हैं? 1 2 3 4 5 6 7 8, and then 9 10 11 12 and 13 and then 14. तो total number of page faults आपके page frame 4 में आपके 14 page faults हैं. Moving ahead with another one, and that is your LRU page frame 3. अब LRU page frame 3 के लिए भी करेंगे और page frame 4 के लिए भी करेंगे. So we'll go ahead and form a table here. So here we have start with page frame, and this is 0, this is 1, this is 2, and this is page fault here. So page fault हम यहाँ पे लिखेंगे, and then after that we'll go have a string here. String में हमारे पास कितने हैं? That is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. So we'll have a 20 here. That is 1, then we have 2 3 4 5 6 7 8 9 10 11 12, then we have 13 14 15 16 17 18 19 and 20 here. So ये हमारे पास आपके पेज फ्रेम्स हैं, इसमें हम स्ट्रिंग्स लिख देंगे, इसके बाद हम इसको फर्दर सॉल्व करेंगे. एंड रेफरेंस स्ट्रिंग की बात करती हूँ, तो लेट विल बी द 1 2, and then we have a 3, then we have a 4, then we have 2 1, then 5 6, and then we have here 2 1 2 3 here, and then 7 7 6 3 2, and then we have 1 2, and then 3, and then we have 6 here. तो ये इस तरह से हमारे पास रेफरेंस स्ट्रिंग्स बचेंगे. एंड नाउ विल काउंट इट ऑन पेज फॉल्स एज वेल एज पेज फ्रेम 0 1 2 and 3 respectively. So here we'll count it on for the page frame 0 here with the LRU page frame 3, and that will be the 1 1, and then again 1, we have a reference string 4, then we have 4 is starting with this, and until and unless the reference string will be the 1, then it will be the 4 only, and that is 5. then 5 रहेगा आपका जब तक आपका 1 नहीं आता, and then after that it will be the 1 here, and जब तक ये आपका more than 6 नहीं जाता, and then फिर 7 है तो 7 रहेगा until and unless it will not come as a 3 2 here, and that will be a 2, and then we have a reference string 2 in the same for the page frame 0 here. For the page frame 1 की अगर हम बात करते हैं, so we have here that will be the 2, and then until and unless it will not come as in the form of reference string, that is will be the 6. So we'll go ahead with 2, and then 6 we have here, so we'll drop that 2 and start with the 6 here, and until and unless that will be the 3. So we'll go ahead, and then we have a 3 here, and then it will continue with the following full reference string with a page frame 1 here. Now moving ahead with the page frame 2 here, and that will be this will 2 not exist, and then we'll start with the 3 here, and then we have a 3, and then after that 1 will be starting with, and then we have a 1 1, and then we'll have a 2 here, and that will be ended until unless the reference string 6 will not occur, and that will be the 6 here, and then we'll start with a 6, and then after that it will be the reference string 1, and then we have 1 here, and then after that we have a 6 here. For the number of page faults we'll count it on, that is page fault यहाँ पे भी है, यहाँ पे भी है, यहाँ पे भी है, and then we have a page fault here also, यहाँ पे भी है, यहाँ पे भी है, यहाँ पे भी है, and then we have यहाँ पे भी है page faults, and then what we have is one यहाँ पे नहीं है, and उसके बाद फिर page fault हमारा है, that is page fault यहाँ पे भी और यहाँ पे भी। अकॉर्डिंग टू दैट फिर वन स्किप करके फिर यहाँ पे पेज फॉल्ट है, यहाँ पे भी पेज फॉल्ट है और यहाँ पे भी आपका पेज फॉल्ट है। तो टोटल नंबर ऑफ पेज फॉल्ट्स अगर हम काउंट करते हैं विद LRU पेज फ्रेम 3, 1 2 3 4 5 6 7 8 9 10 11 12 13 14। तो टोटल नंबर ऑफ पेज फॉल्ट्स जो आपको देखने को मिलेंगे LRU पेज फ्रेम 3 में वो आपके 14 देखने को मिलते हैं। Now moving ahead with another LRU page frame 2K 4K reference में, so we'll make a table here as well as similar to that what we had made LRU page frame 3. So we'll go ahead with a page frame here, that is a page frame, and this is for the 0, this is 1 2 and this is 3, and then we have a page faults here. Okay, so with regard of that we will be having a string here, and that will be your 1 2 3 4 2 1 5 6 2 1 2 3, and then we have 6 7 6 3 2 1 2 3 6 here. तो ये हमारे पास reference string है, so we'll go ahead with the division of in the form of the columns here. So we'll do that, and यहाँ पे ये आपका page frame इस तरह से break हो जाएगा. Then we will do further for the page frame 0, page frame 1, page frame 2, page frame 3. ऊपर वाले में page frame 2 के बाद हमने page faults count किए थे, बट इस वाले में हम page frame 2 के बाद page frame 3 करेंगे, because यहाँ पे page frame जो है वो 4 दे दिया है, and then after that we'll count the page faults here. So we'll do ahead this, as you can see. This I am doing here right now in front of you all, because so that you will get the answer how you will be finding out, because when I will be just writing out all in one, so you will just say that you know or you don't know or you won't understand. So according to that I had made you write right now. So page frame 0 के लिए यहाँ पे है 1, and for that simultaneous when it will be the coming as a string, then until and unless that will be the 1 here. So we'll be having a 1, and then after that 7 we have a continuous, then we have a start with the string 6, and that will be the 6 remain in the whole string here. Okay, so this will be for the LRU page frame 4. For the page frame 1 here, and I will talk about, so that will be यहाँ पे तो existing नहीं होता, and then it will start with the 2 here, and that will be in the whole series, and that for the all the reference string that what it will be given out, we have a reference string that will be in the page frame 1, that will be the 2 here. And for the next we have a reference string, यहाँ पे तो दो existing नहीं करते, फिर then it start with the 3 here, and after that 3 if I'm talking about, so 3 चलेगा, and then after that 5 के बाद वो switch होके 5 हो जाता है, and then after that until and unless जब तक आपका 3 reference string नहीं होता तब तक ये 5 ही रहेगा, फिर जैसे ही 3 आ जाएगा then and that will be remain the same for the whole string, remaining reference string here. So we'll do the same as you can see here. And then after that for the page fault 3 here, तो यहाँ पे आपका ये exist नहीं कर रहा है, and then start with the 4 here, and that will be continuously with reference to the 5, and then we'll go ahead, and then after that for the 6 here it will start with a 6 until and unless that will be the 3, and then after that it will start with a 7 here, and then it will be ending up at the reference string 2, and then we have 1 here, and that will be carried away for the whole string. So we'll go ahead. A number of page faults की बात करते हैं, तो page faults will go ahead and see कि page fault यहाँ पे है, यहाँ पे भी है, यहाँ पे भी है, यहाँ पे भी है, and then after that दो छोड़ के then we have यहाँ पे भी page fault, यहाँ पे भी page fault, and then 3 left करके then we have page fault यहाँ पे भी और यहाँ पे भी है, and then फिर दो छोड़ के फिर page fault यहाँ पे भी है, and then after that it will not having a page fault. So number of page faults कितने हुए, that will be the 1 2 3 4 5 6 7 8 9 and then 10. तो number of page faults जो हमारे पास हैं वो आपके 10 page faults अगर करते हैं LRU page frame 4 में. Moving ahead with another question, and that we'll discuss here is, So here this is the question, and that is, discuss the LRU page replacement policy, prove that this policy do not suffer from Bilady's anomaly, and how many page faults would occur with LRU policy for the following. This reference string we have is 123341534787898789545442. Assume that there are 4 frames which are initially empty. So according to that we have to perform. First we'll understood कि LRU पेज रिप्लेसमेंट पॉलिसीज क्या होती हैं, क्योंकि यहाँ पे इन्होंने बोला है यू हैव टू डिस्कस द LRU पेज रिप्लेसमेंट पॉलिसीज एंड देन आफ्टर दैट उस पॉलिसी को प्रूफ करके कि वो क्या सफ़र नहीं करता बिलेडीज एनोमलीज को, उसके बाद फिर हमें इस क्वेश्चन को सॉल्व करना है. So we'll go ahead here and we'll solve further as what they had given you here. So just for that sake we'll do this, and that is LRU page replacement policies. LRU page replacement policies क्या होती हैं, that what you have to understood in a very clear and concept that you can answer those question as well. So with regard of that LRU page replacement policy, LRU stands for the least recently used. इसमें जो आपका ये LRU है वो होता है least, R stands for recently, and U stands for used. So least recently used, this replacement policy chooses to replace the page which has not been referenced from the largest time. The policy assumes that the recent past will approximate the immediate of the future. The operating system keeps the track of when each page was referenced by the recording the time of the reference or by the maintaining a stack of reference. तो बेसिकली क्या होता है, लीस्ट रिसेंटली यूज़ का मतलब कि जो कोई स्ट्रिंग आपकी बहुत टाइम से नहीं यूज़ की जाती है उसको वो आपका जो होता है वो आपका रिप्लेस कर देता है रिप्लेसमेंट पॉलिसी. Now for that we have another point reference to this policy only. System must maintain a time span for for every page that indicate the time of the last access. When the deciding page to remove, the operating system must scan all the pages of the memory for finding out the oldest time span. Instead of keeping an extra time span bit, LRU is implemented by maintaining the page in an ordered list here. तो सिस्टम जो है आपका ये ना मेंटेन को करना चाहिए, उनको मेंटेन करना चाहिए टाइम स्पैम को, कि हर एक पेज जो है वो आपका इंडिकेट करे एक टाइम पेज जब कि वो लास्ट कब एक्सेस हुआ है, और फिर वो डिसाइड करेगा कि कौन सा पेज को रिमूव करना है. ऑपरेटिंग सिस्टम को स्कैन करना चाहिए हर एक पेज को मेमोरी में कि जब कि वो फाइंड कर सके कि सबसे ज़्यादा ओल्डेस्ट टाइम किसका है. और ये नहीं कि सिर्फ उसका एक्स्ट्रा टाइम स्पैम बिट्स को ही सिर्फ आप ले रहे हो, उसके साथ साथ आप LRU को भी इम्प्लीमेंट करो कि आप पेज के ऑर्डर्ड लिस्ट को मेंटेन कर सको. Next with the policy only we will discuss more further, and then we'll discuss a question here. This system can manage LRU with a list called that is LRU stack. जो system हम लोग manage करते हैं ना LRU के reference list में, तो वो हमारा LRU stack होता है और paging stack. In the LRU stack, the first entry describes the page reference least recently. The last entry describes the last page referenced. If the page is referenced, move it to the end of the list here. So LRU algorithm does not interface with the locality of the process. LRU algorithm जो है वो आपका इंटरफेस नहीं होता कि वो कौन सी locality of that particular process से belong करता है. So here we'll do a question reference to this policy only. Consider the reference string, that is we have 1 2 3 4 2 5 3 4 2 6 7 8 7 9 7 8 2 5 4 9 here. With reference to that we will go ahead with the page frame. अगर हम बात करते हैं अब हम पेज फ्रेम जो साइज लेंगे वो हम लेंगे दैट विल बी इक्वल्स टू 3 ईयर. अब हम इसके लिए रेफरेंस टेबल बनाएंगे, दैट इज हाउ वी विल फाइंड इट आउट द नंबर ऑफ पेज फॉल्ट्स इन दिस पर्टिकुलर रेफरेंस स्ट्रिंग. उसके बाद इसी के रेफरेंस में हम फिर पेज फ्रेम 4 साइज यहाँ पे 3 लिया है, फिर उसके लिए हम पेज फ्रेम साइज 4 ले लेंगे, हम उसके रेफरेंस में इसको सॉल्व करेंगे. देन उसके बाद उसमें नंबर ऑफ फॉल्ट्स कितने हैं वो उसको भी देखेंगे. So we'll move ahead with reference to this only, and that is also an important to how to find it out all these strings here. For that sake we have a reference string. We'll just write it down here. ये आपका reference string है, okay. And then we have here page frame 1, page frame 2, then we have page frame 3 here, and then we have first we have page faults here. Okay, तो ये हमारे पास यहाँ पे है. So according to that we'll perform here, and according to that we will be finding out the values as well. So we'll just have a string here, so we'll just write it down here. This is 1, and then we have 1 here, and then we have 2, then 3, then 4, 2, 5, 3, 4, 2, 6, 7, 8, 7, 9, 7, 8, 2, 5, 4, 9. So this will be the whole string here. So we'll just differentiate these strings in a single column here, so that we can find it out all these in a easy way here. So we will separate these. This would be in the form of a table, that what you're meeting for that reference string when we are finding out. So you just go ahead with this. So yeah, this is will be the table that will form here, and with reference to that we have to find out the page faults as well. So we'll go with page frame 1 जब है यहाँ पे, तो that will be the 1 and then again 1, and then 4 string आ जाएगा तो 4 रहेगा, and it will be until unless that will be the 4 here. Then we have a 3 reference string that will occur, and then after that 6 आएगा, तो फिर that it will be the 6 here, until and unless इससे ज़्यादा नहीं आता तो 9 आ गया, तो यहाँ पे 9 आ जाएगा reference string, and until and unless जब तक 2 नहीं आता, and then it will be the 2, and then we have a 9 here. This is for the page frame 1. Now moving ahead with the page frame 2, it will not exist. This will be the 2 here, and that will continuous until and unless that will not in the reference string that will not come as a 4. Okay, so there it is, will be the 4 here, and for this 4 we'll have 4 here, and that is for the till the 7, and the 7 that will exist till when it will be not 5. So we'll go ahead, moving ahead with this, and the 5 nahi aata, so we'll have 5, and then after that we'll have a 5 string here. With for the page frame 2, page frame 3 की बात करते हैं, तो we'll have here that will be this, and then after that 3 है तो ये 3 रहेगा 3, and then we have a 5 here, and that will be 5 here as well, and then we have a 2, then first we have a 2 here, and then we have 8, and that will be a move of further here, and then after that we have 4, and then we have 4 here. So after that we have a page faults यहाँ पे भी है, यहाँ पे भी है, यहाँ पे भी है, and then फिर यहाँ पे भी है, and that will be here also, and after that one skip करके फिर यहाँ पे भी है, यहाँ पे भी है, and then फिर यहाँ पे भी है, यहाँ पे भी है, and then यहाँ पे भी है, यहाँ पे भी है, and for that sake we have page fault here also, and after that we have page fault for the reference string 9 also. Then we have page fault reference string for the 4 or 2 here, and then we have our page faults everywhere. So total number of, अगर मैं बात करती हूँ तो total number of आपका जो page fault है वो देखते हैं कहाँ पे है, and that कितने हैं, like 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15 and then 16. तो total number of page faults जो है वो आपके 16 हैं, with a page frame size 3 for this reference string. Now moving ahead with another page frame size, that is page frame 4, and with page frame size 4, and then we'll count it on total number of page faults here. So here we have a page frame size that is 4 here, and for that sake we'll do ahead, and then we have a reference string की अगर हम बात करते हैं, so we'll have a reference string here, and that is यहाँ पे page frame 1 है, page frame जो आपका है that is 2 here, and for that here page frame आपका 3 है, and then here we have a page frame that will be the 4 here, and then we'll count it on the page fault as well. Okay, so this will be counting out, and here we have a reference string, as you can see, that is 1 2, and then we have here it will be the 3, and then we have a 4, then 2, then 5 3 4, and then 2 6, then 7 8 7, then 9 7 8, and then 2 5 4 9 here. For this reference strings we have here, as we can differentiate between these strings, so that will count down your page for page frame 1, page frame 2, page frame 3, and page frame 4, as well as comparing to that page frame of faults also will count it down for the page frame size 4 here. So हमें यहाँ पे basically जो count करना है वो total number of जो आपके page faults होंगे वो count करना है, और बिना इसको find out करे, बिना table को form करे हुए आप नहीं निकाल सकते हो। वो बात अलग है कि ट्रिक आपके पास है, बट उसको अगर आप हर जगह पे नहीं यूज़ कर सकते हो, इसलिए मैं यहाँ पे टेबल आपको बनाना इट्स कंपल्सरी, and so that you will find out the answer accurate as well. And with reference to that, we have a table here, and then we'll find it out all these things. So we'll go ahead. चलो अब फाइंड आउट करते हैं पेज फ्रेम 1 के लिए। यहाँ पे फॉर द पेज फ्रेम साइज 4 here. So this is page frame for 1, and this will be start with 1, and that will end up with 2 when we'll get 2, and then we'll have 5 strings. So we'll move ahead with 5 until and unless जब हमें इससे ज़्यादा नहीं मिलता, जब तक that is 6 here, तो फिर 6 start होगा, and then until and unless that will come as in the form of a 2 here, and that will be the 8 के बाद 2, then it will be forwarded by the 2 here for the page frame 1. Page frame 2 की बात करते हैं, so we'll have this will be not existing, this will be the 2 here. With the reference string 2 की बात करते हैं, so it will be the until and unless with page frame 2 reference to the page frame size 4. So it will be the 2, and then until and unless that will be the 9, and that will occur, and it will goes more on further, and then after that it will be 5, and that is move on further for the page frame 2 here. For the page frame 3 we'll have this will not exist here, and of course for this reference string 3 here, so we'll start with 3, so this will be the 3 as well, and that will exist till when we'll not received more than this, and that will be the 3 as well. So here also it will be, and this will occur, and then it will occurs as a 7 here, so we'll go ahead with a 7, and that will be carried out as 7 until and unless it should be 4, and that will be carried out moreover. With reference to the page frame 4 here, it will not exist here in all these threes, and then it will occur 4, and it will move on further until and unless it will not occur as in the string that is 8 here. 8 jab aayega, that it is moreover move on, and it will be the 8 only, and then after that it will be the 9. Now we'll count down the total number of page faults. So here it will be page fault, here will be page fault, it will be page fault, and this is also be page fault, and then we'll one leave, and we'll be having a page fault here again, and then after that leaving 3, and then we have a page fault here, and then we have a page fault here also, and page fault here also, and one leaving, and then we have a page fault here also, and then we leave a 2 here, and then we have a page fault here also, page fault here, and then page fault here, as well as page fault here also. So we'll have 1 2 3 4 5 6 7 8 9 10 11 12 13. So total number of जो हमारे यहाँ पे page faults हैं, that is total number of page of faults we have here is 13. So with regard of this, we'll move ahead, and that is your LRU is a stack algorithm, and that increase in the memory size will never cause an increase in the number of the page interrupts. Now we'll discuss the advantages as well as the disadvantages of this replacement algorithm. The advantages is it is a quite good algorithm, क्योंकि ये थोड़ी कुछ ज़्यादा अच्छी algorithm है जिसमें हम actually में find out कर सकते हैं number of page fault in an easy way. It is amenable to full statistical anomaly and never suffers from the Bilardi's anomaly. Bilardi's anomaly कभी भी ये suffer नहीं करती, और ये आपका पूरा statistical anomaly है. डिसएडवांटेजेस की बात करते हैं, तो दो डिसएडवांटेजेस हैं. फर्स्ट डिसएडवांटेजेस इज प्रॉब्लम इन हाउ टू इम्प्लीमेंट, कैसे इम्प्लीमेंट किया जाए, ये थोड़ी प्रॉब्लम रहती है, फेस करने को मिलती है. दैट इज़ द डिसएडवांटेज, एंड इट रिक्वायर्स हार्डवेयर असिस्टेंस, और इसमें आपका हार्डवेयर असिस्टेंस रिक्वायर्ड होता है. दिस इज द अनदर डिसएडवांटेजेस हियर. Now moving ahead with another one, and that will discuss the reference string what we had discussed here, and will form a reference string of whole where we can find it out and in reference to the string here. So here we will make a table here, and that will be the 0 for the page frame 0. This is for page frame 1, this is for page frame 2, and this is for 3, and this is will found out the page frame here. Okay, so that is will be the page fault we'll be finding out. So we will be having here the reference string, that will be the 1, the 2, 3, and then again we have a 3 here, and then we have 4, then 1 5 3, then 4 1 6 7 8 7 8 9 8 7, and then we have here will be 8 9 5 4, and then we have 5 4 and then 2 again. तो उसके रेफरेंस स्ट्रिंग्स के हिसाब से अगर मैं बात करती हूँ पेज फ्रेम के बारे में, सो वी विल गो अहेड एंड फाइंडिंग आउट. तो विद रेफरेंस टू द पेज फ्रेम 0 अगर हम बात करते हैं तो लगभग 8 तक जितने भी है वो सारे ही आपके वन ही है. तो अकॉर्डिंग टू दैट वी विल बी हैविंग हियर and that will be your this will be till the 1, as then after that 8 के बाद 9 की बात की अगर मैं बात करती हूँ तो we will be having here 9, so we'll be further having 9 here for all that string here. Okay, so next we have a skip here, and then we have a 2 here. Until and unless it will not occur as 5, so we'll move ahead, and then it will be the 5 here. And until and unless that will be coming a 6 here, so we'll move ahead with 5, and then it will be 6, though it will be going on with a 6 as well. And just see यहाँ 5 मिलेगा string, that is will be the 5, and then it will more further, that will be the 5 here. For the page frame 2, then we have a here 2, and then after that we will be having a 3 here. Until and unless that it will not occur as a 7, we will be having same, so it will be 7, then it will be the 7 here, and that will until and unless that will occur as a 4, and that it will be 4, and then after that it will be forwarded by 4. Then after that for the page frame 3, it will be not occurring till the 3, so it will be occurring at 4, so 4, and that this will occur until and unless that will be the 8 here, as you can see. And 8 पे जब वो आपका 8 अगर आएगा तो it will be whole in the series, that will be the 8 here. Okay, and after that page faults की बात करते हैं. So we have a page fault here also, page fault here also, and page fault here also, and then we have page fault here also, and then after that one leaving, and then we have a page fault here also. Then according to that page fault यहाँ पे भी है, यहाँ पे भी है, और फिर यहाँ पे भी है, and फिर इसके बाद यहाँ पे भी है, and then we have दो छोड़ के फिर यहाँ पे भी है, and then फिर वो लास्ट में भी है. So और टोटल मेरे पास जो जितने भी पॉज फॉल्ट होंगे जो 3 3 6, and that will be 9, and then we have 10 11, that is 12 page faults हमें यहाँ पे देखने को मिलते हैं. Moving ahead with another question, and that what we have to discuss, and what we have to made a table here as well. So with reference to that we have a question here, that is how many page fault would occur for optimal page replacement algorithm with the following reference string of the 4 page frame. 4 page frame के लिए आपको इसको नहीं बताना है. ओके, इसके लिए बोला गया ऑप्टिमल पेज रिप्लेसमेंट भी आपको फाइंड आउट करनी है विद रेफरेंस टू दैट फॉर दिस रेफरेंस स्ट्रिंग 1 2 3 4 5 3 4 7 6, and then 7 8 7 8 9 7 8 9 5 4 5 4 2 here. So here we have optimal page replacement, so we'll go ahead and we'll just find it out for this. So first we'll write it on the string we have as 1 2 3 4 5 3 4 7. Then we have sorry, this will be not 7, this is 4 के बाद ये 1 है. Okay, this will be the one here. Then we have 6, then 7, then 8, फिर 7, फिर 8, फिर 9, 7, then 8, 9, 5, 4, 5, 4, and then we have 2 here. With regard of this, we'll just find out the page frame 0, 1, 2, 3, and then we'll page fault. So 0 page fault, page frame के लिए 1, फिर page frame 2 and page frame 3, and then we again have to find out for the page fault here. Okay, so these were the page frame and this was the page fault. So we'll just divide it by this for the reference string, so that we'll be finding out in an easy way here that what we have here is. So we'll just divide that. So as you can see here, we are using this with optimal page replacement. That is also important. As I told you, this has been asked in the 2009 and 2010 as well, and that has been asked in the many of the times, but you have to know how to solve the LRU page replacement algorithm, as well as how to solve FIFO, that is first in first out of page replacement algorithm, as well as you have to find out how to find out the optimal page replacement algorithms. Then you will be able to find out the whole concept. If you have cleared about the concept, you can just find it out with this. So we'll just go ahead and just find out for the page frame 0, page frame 1, and page frame 2 here. So here we'll go ahead and find out, and we will find out how total numbers of page frame that will occur here. For the page frame 0 here, if I'm talking about the string, so it will go until and unless that will not come and exceed maximum or value here, and that will be the 6. So we'll be starting with 6 here, then 6 से ज़्यादा फिर यहाँ पे 8 आ जाएगा, तो 8 आएगा, and that will be for the following whole string until and unless it will not come as in the form of the string 2 here. So it will be the 2. Then after that, for the page frame 1 here, this will not exist, and start with the page different string 2 here. Fit 2 के बाद यहाँ पे आता है, that will be the 5, and then it will carry it away, and it will carry it away until and unless that will be not end up this string, because it will only take it out as a string of page frame 1 here. So it will be the 5 only when we are using the optimal page replacement algorithm. Okay, then now for the page frame 2 here, so we'll start with 2 here, and that will be the 3 starting from the 3, because here we have a reference string 3, and until and unless it will not count as a 7, so we'll just start with the 7 here, and that will be goes on until and unless it will not end up with it will end up with at the reference string of the 4 here, and then it will be there. And for the page frame 3 here, I will start with the third here, that will be starting with 4 reference string, and that will be continuously until and unless we will not get the reference string that will be just 9. So then it will be occur as 9, and then after that starting with the page frame here, then it goes on and it completes here. So this is a reference string, so we'll count on the page frame here, and that will be, so page frame यहाँ page fault यहाँ पे भी है, page fault यहाँ पे भी है, and this is also page fault, and this is also page fault, this is also page fault. After this, we have here is your after 3 that we'll be getting here page fault, page fault, page fault, and then we have again leaving the 2, and then we'll go ahead with page fault of 4 here, and then we'll get the for the reference string that will be coming here is page fault, and then after that in the last we'll get page fault. So total number of page faults we are occurring here is 1 2 3 4 5 6 7 8 9 10 11. So total number of page faults we have here is 11. Moving ahead with another question that will discuss the page replacement algorithm, and where the algorithm that is available for the page replacement that we'll discussed here. So this is the algorithm available for the page replacement. So name of the algorithm available for the page replacement, we have FIFO page replacement algorithm, LRU that will be the page replacement algorithm, as well as the optimal जो भी अब हमने discuss किया optimal page replacement algorithm. तो 3 तरह के एल्गोरिथम है जो कि आपके पेज रिप्लेसमेंट एल्गोरिथम के लिए यूज होती है। पहले देखते हैं फीफो, दैट इज अ फीफो फर्स्ट इन फर्स्ट आउट पेज रिप्लेसमेंट एल्गोरिथम removes the page that have been memory in the longest. Here the system keeps a track of the order in which page enter the primary memory. तो जो सबसे पहले आएगा वो सबसे पहले जाएगा भी, and that will the page replacement algorithm follows the concept that it will remain the longest time जो रहेगा वो memory में जो सबसे पहले आएगा वो सबसे पहले भी जाएगा. For the LRU stands, that is the LRU stands for the least recently used. This replacement policy chooses to replace the page which has not been referenced by the longest time. This policy assumes that the recently past will approximate the immediate future here. जो recently passed हुआ है वो immediate future हो सकता है. That what least reference least recently used वाला आपका used हो सकता है. And with regard of this, we have a third algorithm with reference to the page replacement algorithm here, and that will be the page optimal page replacement. The data which will not be accessed permanently or for a longest time should be replaced in the optimal page replacement algorithm. तो जो आपकी optimal page replacement है algorithm है वो ये बताता है कि ये वो data है that is not accessed permanently or for the longest time, that should be replaced in the optimal page replacement algorithm here. Moving ahead, we have thrashing. What is thrashing? That is also important. And but before that, till now you will be able to like if veladies and anomalies के बारे में पूछा जाए, like popular page replacement algorithm जो कि आपके veladies and anomalies को suffer करते हैं, as well as with demand of that how to find out the system that is in the single process of CPU idle page swap that we had discussed here. So after that I will discuss the thrashing here, and that is also an important topic reference to the competition wise as well. The phenomena of excessively moving page back and forth, that is between the memory and the secondary storage, has been called thrashing. Thrashing क्या कहलाते हैं? वो phenomena जहाँ पे आपका पेज जो है वो back and forth मूव करता रहता है मेमोरी से सेकेंडरी स्टोरेज में, उसे ही हम thrashing बोलते हैं. Thrashing के definitions के बारे में अगर हम बात करते हैं, so we have another definition as well. So thrashing occurs when a process does not have enough frames allocated to store the page. It uses repeatedly. The page fault rate will be high, very high. So basically क्या होता है, thrashing जो है वो आपका तब अगर करता है जब आपका प्रोसेस जो है वो आपका enough frames allocate करता है और वो स्टोर भी करता है उसको repeatedly. पेज फॉल्ट रेट जो उसका होता है वो हाई भी हो जाता है. With reference to the thrashing, we have another point here. So a page fault occurs when an access to a page that has not been brought into the main memory take place. The operating system verifies the page access, aborting the program, and if it is invalid, then if it is valid, a free frame is located. If no free frame is available, a victim page is selected and it is freed from the frame it occupies. Input-output requested to the victim page is dirty. So if this victim page is dirty, here input output requested to the read the new page into the free frame, where that is upon completions of input output and the process table, that page table has been completed and the instruction is also restarted. With reference to the thrashing, if I'm talking about, so in a simple words we can say that the thrashing is a situation where whenever a process needs to run, it swaps out some other process working set on a disk, and this happens when all the process working set size some are too large than the amount of the physical memory available in the system. Where in terms of the thrashing, we can say that thrashing can be detected by the system when the CPU utilization start decreasing and the number of pages faults increases considerably. With reference to the thrashing, we can say that to eliminate the problem, the system can either decrease the degree of the multiprogramming or can use the local, or you can say the priority replacement algorithm as well. Now this all about the thrashing. We'll discuss moreover regarding the cache memory organization. Cache memory organization के reference में हम बात करते हैं. So cache memory organization, cache line consists of two fields. So cache line जो है वो दो fields आपकी consist करती है. First is your data from RAM, that is random access memory, and that the address of the block currently in the cache, जो भी address block में होता है currently वो cache के through ना, तो वो वाली चीज़ें contain करता है. With reference to the cache memory organization, the part of the cache line that stores the address of the block is called, that is a tag field, and that many different addresses can in any of the given cache line. The tag field specifies the address currently in the cache line. Where in the reference to the cache memory, we can see that the cache memory is divided into the blocks of or lines. Currently, lines can range from 16 bytes to that is of 6 to 64 bytes here, and the data is copied to and from the cache one line at a time. The memory system has to be the quickly determined if the given address is in the cache. There are three popular methods of mapping addresses to the cache location. There were the three methods that were the methods we have here is this is the fully associative, direct, and set allocation. If I'm talking about fully associative, with a fully associative, it stands for that search the entire cache of for an address, and where in an associative cache memory, the data from any location in the RAM can be stored in any location in the cache. When the processor wants an address, all the tags field in the cache as checked to determine if the data is already in the cache. Each tag line requires a circulatory to compare the desired address with that tag field. All the tag fields are checked in parallel in the fully associative. Where reference to the direct here, so direct, in the direct that each address has a specific address in a cache, and where each location in the RAM has on one specific place in the cache where the data will be held. So we can consider that the cache to be like an array. A part of an address is to be used in the index into the cache to identify where the data be held. So since the data are blocked from a RAM, so that can only in a one specific line in a cache, and it must always replace a one block that was already there, and there is no need of replacement algorithm in the direct here. So with direct mapping, now I will discuss about the set associative, and here with the set associative, each address can be in any of the small set of the cache locations. Where it stands for that set associative mapping is a mixtures of direct and associative mapping. The cache lines are grouped into the sets, and the number of lines in the set can vary from 2 to 16. Here in the set associative, it could vary to 2 to 16 as well. 2 to 16 as well as that can vary, and the proportion of that address is used to specify which set of that can be held an address. And the data can be stored in any of the lines in the set, and that the processor wants to address it, indexes to the set of, then searches that tags of that lines in the set of for and desired. Reference to the cache memory, अगर हम बात करते हैं, where the caches are the introduced into a system to a buffer to a mismatch between the main memory and the processor speed. A cache is a relatively small fast memory placed between the processor and the main memory, and the cache is designed so that it access the time matches the processor cycle time. Where the cache memory in a high performance single chip processor being built together, the cache memory is actually built on the processor chip and separated into the distinct instructions and the data caches, as well as the typical size of these caches is your. In reference to this, so we have 8 kb for a total number of that we have 16 kb of cache of the processor chip. Many system designs also include the octet cache, and which is called the second level cache, and that will assigned as the L2 cache here, that is the second level cache here. When the processor makes a memory request, the request first passes to the memory cache. If the data items is found in that cache, we have a cache hit, and if the data is not found in the primary cache, so then we have a cache miss, and the memory request is forwarded to the L2 here. So we have an L2 cache here and hit, and that is a data passed back to the memory cache. And if the data is not found in the L2 cache, so we can see that that the request is finally forwarded to the main memory here. Okay. So when the main memory responds to the memory request, the data item is passed back to the L2 cache and then the primary memory as well. Now we'll discuss another topic, that is allocation of frame, and that what we have to discuss, and this is the last topic of this unit, that is unit 4, that what we had discussed about memory management here, and the last topic of the session, that is allocation of frame. So allocations of frame, here we will discuss that the allocation policy in virtual memory system governs the operating system decision regarding the amount of the real memory to be allocated to each the active processor. With this, in the paging system, if a more real pages are allocated to a process, then it reduces the page fault frequency and improve the turnaround time. If two people's a few pages are allowed allocated to the process, its page fault frequency and the run around time, you can see that turnaround time may deteriorate to unacceptable levels level. With respect to this, the minimum number of the frames per process is defined by the architecture, whereas the maximum number of is defined by the amount of the available physical memory. And the easiest way to split in frames among n processes is to give the everyone an equal share. That is, you can say that m by n of frames here. With this scheme, this is called equal allocation. With the multiple process completing for the frames, we can classify page replacement algorithm into the two broad categories. The first category is your local replacement, and the second category is your global replacement here. With a reference to the local and the global here, local replacement requires that each process selects from only its own set of allocated frames. And for the global replacement allows a process to select a replacement frame from the set of all the frames, even if that frame is currently allocated to the some other process. One process can take a frame from the another as well. With regard of this, if I'm talking about the minimum and number of frames per process is defined as by the architecture, whereas the maximum number is defined by the amount and the amongst of available physical memory as well. So here we'll end up this lectures where we discussed about the last topics as reference to the memory management. In regard of this, if I'm talking about what we had discussed before this, so as accordingly we had discussed the first chapter unit. This is your introduction, where we discuss about the operating system, and functions, classification of operating system, batch interactive system, time sharing, real-time sharing, multiprocessor system, multi-user system, multi-process system, multi-threaded system, operating system structure, layered structured system components, and as well as operating system services, redundant kernels, monolithic, monolithic systems. Their system called booting PCs, kernels. All these we had discussed in here. Then we had discussed your unit 2, where we had discussed about the concurrent process concept, principles of concurrency, producer consumer problem, mutual exclusion, critical sections problem, Decker's solutions, Peterson's solutions, semaphores, tests and sets operations, classical problem in the concurrency, and the dining philosophical problem, sleeping barber problem, inter-process communication models and schemes in the process generation as well. Where we had discussed unit 3rd, where we have discussed about the CPU scheduling concepts, performance criteria, process states, process transition diagram, schedulers, a process control block, and process management scheduling algorithm, and the multiprocessor scheduling deadlock as well, system models, and the deadlock characteristics, preventions, avoidance, and the detections, recovery from that is from deadlock. Then we had discussed unit 4, जो कि आज हमने क्लास में कंप्लीट कर लिया, that is memory management, basics, Beers machine, recidental monuments, that monitors multiprogramming with the fixed pattern multiprogramming, and the variables, partitions, protection schemes, paging segmentation, page segmentation, virtual memory concepts, demand paging, performance of demand paging, and page replacement algorithm, thrashing, cache memory allocation, and the locality of references, that what we had discussed here. And after that we'll discuss unit 5, that is input output management, the disk scheduling, input output devices, input output subsystem, input output buffering, disk storage, disk scheduling, RAID file system, file concept, file organization and access mechanism, file directories and file sharing, and file system implementation issues, and file system protections and security, that we'll discuss in the next coming classes. So class आज के लिए इतना ही. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion or comment box. Please like, share, and subscribe our channel so that many and maximum people can get the information at once. Thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.